Hi, welcome back. We are in our second topic, still on the first week. Hopefully you haven't had any problems with the first set of videos. So let's get started with the second set of videos. But first I want to make sure, are you breaking up when you're studying? I hope you're not trying to watch all the videos right in a row, because you're going to get a lot less out of the content. There is a lot of brain fatigue sitting at a computer. So definitely break up the content and watch it and get the most out of it. If you have any questions about the course this semester, be sure to write to me through Canvas. Um, so let's get started in our conversation about chemistry. Um, so in this first section about chemistry, let's start talking about matter. What is it? Well, matter is defined as anything that has mass and occupies space. You learned in grade school that matter had three forms: solid, liquid, gas. We're not really going to be concerned about that in this course. Um, what does this mean, has mass? Well, for this class, we'll just talk about, like, we can weigh stuff. You have a mass. Here on Earth, we have gravity, you have a weight. You occupy space. For this course, that it's very simplistic, but that's all we care about. Okay. I also want to introduce the concept of energy. We're going to step away from it, but we'll come back to it later. Energy just means the ability or the capacity to do work. And we require energy when we have matter that we want to break up. We want to blow it up into smaller pieces. We also need energy when we want to take small pieces like Legos and put them together to make something bigger. And we also talk about different types of energy. We have what we call kinetic energy, and we have what we call potential energy. Kinetic energy is when we have energy in motion, as opposed to potential energy, which is when we have stored energy. So when you're riding your bicycle up a hill and your legs are pumping, that's kinetic energy. And once you reach the top of the hill and you're stopping, you've got a lot of potential energy stored, because as soon as you go down, you can coast going down. So the thing about energy is we can't create it. We just can move it from one type of energy to a different type of energy. So the basketball at the top has a lot of potential energy, and then we're going to release it when it falls. So we have lots of different types of kinetic energy in motion that can be transferred. When we're talking about light, that's energy. Heat, that's energy. Sound, that's energy. So we can have sound energy coming into our ears, and then that's going to be changed, and we're going to have wave energy for the liquid that's in our inner ears. And then that's going to get changed, and we're going to have neural impulses in our brain, and that's how we're going to be perceiving sounds. So we're basically going to be transferring one type of energy to another type of energy. So take a moment, stop the slide, stop the video, and do a quick think about these two pictures and what type of energies they are. Okay, that was pretty easy. So let's move on to the next topic, talking about elements and atom, reminding you that matter is anything that has mass and volume. And matter is made up of one or more elements. And when we're talking about the elements, I want to refresh your memory to that periodic table of the elements that you learned about probably in high school. And there were like 118 different known forms of matter, some of them naturally occurring, some of them man-made. We see them arranged in tables and columns where there were like things where we could be breaking them down to commonalities. We don't really care about that in this class. But the thing about these elements is they are the most basic parts of what they are, so they cannot be broken down. Helium can't be broken down into anything more basic than what it is. Same thing with carbon, same thing with aluminum, same thing with magnesium or potassium or calcium or lithium or sodium or manganese or magnesium. They are what they are. They're the most basic elements. Now, they are made out of smaller particles, and those particles are called atoms. So an atom is the smallest unit of an element that retains the characteristic of that element. And yes, atoms are made of smaller particles. And so originally, we thought that atoms were made out of, in the center, they had the neutrons and the protons. And then they're surrounded out in the atomic cloud by the electrons. The number of proteins equals the number of electrons, so that there is no net charge. And over time, our knowledge has increased. So now we know that there's other particles such as quark and leptons and Higgs bosons and even the wonderful little neutrinos. So our knowledge is constantly evolving. So with experiments, our facts are and what we think is scientific theory is evolving. But we're not going to go into much more depth about that in this course. Of those more than 100 different elements, there's only 25 of them that we need in our human body to stay alive. And of those, there's 4 biggies. Okay. And so look at this model drawing of a human, and what you'll realize that those 4 elements are going to account of 96% of this human. And when we look at this human, you can see that orange is more than half, and that is oxygen. The next big chunk up here in purple is carbon. Whoops. And then the next larger chunk is hydrogen, and then there's a smaller little green piece that is nitrogen. So those are the 4 biggies that you need to know. It kind of makes sense if you think about water, because all of you know our bodies are a lot of water, and water is hydrogen and oxygen. Okay, so there's your H and your O. And then you throw carbon, and then our air is mostly nitrogen. So you throw nitrogen into the mix, and that's the big 4. Now, the next 7 elements make up 4%. And of the next 7 elements, the 5 that we will talk about in this course would be calcium, phosphorus, sodium, chlorine, and potassium. And actually, we'll talk about calcium and phosphorus. You know about those already, making bones strong with calcium. Sodium and chloride, those and potassium, those are going to be important with relationship to blood pressure. And then we have a whole bunch of trace elements that add up to about 0.1%. So we may mention a few of those as we're going along, but essentially we're going to ignore the rest of those. So let's go back to these elements and these atoms and talk about how they get put together to make things we call molecules and compounds, and what the difference is between the two. If you have 2 or more atoms that are going to be held together by a chemical bond, and I'll talk shortly about what chemical bonds are, that's going to be a molecule. So if the 2 molecules are held together, if the 2 atoms are held together as a molecule, so there's an example of 4 different molecules. Now, if we have 2 different type of atoms, or 3 different type of atoms, or 4 atoms, of which there's at least 2 different type of atoms, you see where I'm going to, that's called a compound. Okay, so water, because it has 2 different types of atoms, that would be a compound rather than a molecule. Carbon dioxide would be a compound rather than molecule. Oxygen is just a molecule because it's 2 oxygen molecules together. For simplicity in this course, I'll probably just be using the word molecule all the time. And I'll be talking about what I mean? Because all compounds are molecules, but not all molecules are compounds. So there is a distinction, but by saying the word molecule, it is correct, whether it's a compound or just a molecule. All right. So here's another quick thing, and this one you will have to turn off your TV screen for a little bit. I've got 3 different things going on. One, I have 3 scoops of what looks like strawberry ice cream. One, I have a scoop of 7 different types of ice cream. One, I have a list of flavors, and one, I have 1 scoop. So I want you to go through and figure out which one is which, and then come back and read and rejoin me for the next video, because that's the last slide for this video. So thanks again for putting in all the work, and I will see you shortly.